All right, so now we're back and we're going to put all this stuff together. So we've looked at percentiles, we've looked at quartiles, and so now our 5 number summary and the box plot. So another way to summarize special values within a data set is to use a box plot graph. So the 5 number summary, first of all, consists of 5 things, 5 numbers. So we have the minimum, the first quartile, the median or the second quartile, the third quartile, and the maximum. So the one thing to be careful about is don't confuse these maximum and minimums with the range rule of thumb. So that's looking at significant values. This is not that. So this is just what is the actual minimum, what is the actual maximum in your data set. So once you have those 5 values, then you can put them into this box plot, or it's also called a box and whiskers diagram. So it contains those different values. It's using a number line typically to help, just kind of frame the whole situation. And then so you'll get something that looks like one of these, similar to some of these different types of examples. So we have this box plot here, so we can see the minimum value, the maximum value, and then we got our 3 quartiles in the middle, and they kind of form a box around those 3. So in this case here, you can see the minimum is pretty close to those quartiles, and then the maximum is way the heck out here. So in this case, you can kind of see that it is skewed, and more specifically, we probably have an outlier, minimally of one outlier of 2840. So that's way out beyond the rest of our data that's down here. So it just gives you that visual of what's happening with your data. So now let's do that for our previous example. So remember we had all those different budget amounts and we found some quartiles. So 35, 68, 113. So let's just put all of that data down so we have it. So the minimum is 4.5. First quartile was, I already forgot it, 35. And then 68, and then 113, and then the maximum is 225. So we want to make sure we at least get these 2 extremes on our number line somewhere. So, and then that means the rest of them will be in there as well. So okay, so we have to scale our number line, first of all, to make sure that it accommodates our data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dashes. So 12 dashes, and we're looking about, even if we started at 0, would probably be fine. So we're looking at 0 to 225. So if we wanted to get an idea of how big to make each space, we can kind of use that as a reference. So we're really looking at 225, and let's divide that by 12. So 18.7. So let's make that a little bit more user-friendly. Let's round it up to 20. So if each space is 20 units, that should hopefully, accommodate everything. Now you might have to adjust that, but, just trial and error. So if we wanted to start at 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220. So we are a little bit short of our 225, but we do have a little bit of extra space, so we can extrapolate, where 225 should fall. So we'll be okay. All right, so once you have that, now you're just drawing some lines that correspond to your 5 key points. So 4.5, well, halfway would be 10. Half of that is 5, which is pretty close to 4.5. So about a quarter of the way. So there's 4.5. I like to label it up above, but it's absolutely not a requirement, but it's nice to do that. 35, so 30 would be halfway between, so 35 is about 3/4 of the way. 68 is pretty close to 70, which is right in the middle, so maybe a smidgen to the left. 113, so 110 would be in the middle. 113, 115 would be about here, so it's really between halfway and 3/4. So again, you know, try to get it as close and logical as you can. Obviously, you don't want to put 113 closer to 110. So, I mean, just try to make it make sense. And then 225 we can see is way up here. So again, halfway would be 230, so half of that. So right about in here is our 225. So there's our 5 lines. Now we just got to connect the dots and make it look like a box plot. So the first thing, let's get the line right down the middle. Make it as best you can. So there's that. Again, don't go beyond. You want to stop at those 2 limits. And then in the middle 3 are connected, top and bottom. And then you're done. That's it. Pretty quick to draw it. But again, the scaling is going to be important. And then, you know, just getting those lines in there and stuff. So. All right, and then again, we can do some sort of analysis as far as, okay, well, 225 looks like it might be an outlier. It's a little bit beyond our quartiles. You know, the low end is fairly close. So, you know, we can kind of give that general overview of it. But let's take a look at the last one, just to do it one more time. So if we want our min, we can see that's 1. Our max, we can see is 23, and then we need our quartile. So Q1, so we need our L first of all. So how many values do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 values in here. So we got, let's see. So remember our formula. So we need K over 100 times N. So first quartile is 25%. So that will give us our value. So 25% of 14 is 3.5. So that means we got to go to 4. So the 4th value in our list, so 1, 2, 3, 4, which is a 4. Q2, that is going to give you a 7. And so we just picked the 7th value. Hopefully you caught that. Remember, when L is a whole number, we have to look at that number and the next. So we need the 7th and 8th. So 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we're going to average 6 and 7, which we can do in our head, 6.5. And then our last value, 75 times. Okay, so that's going to be what, 10.5, which is 11. So the 11th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's a 7. All right, so now we have our 5 numbers. So now we got to get our scale. So we got 12 dashes again, but now we're going up to 23, starting at 1, starting at 0. So let's just pretend it's 24. 12 dashes, 24. That's 2 points, or a spacing of 2, a scaling of 2. So if we start at 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So same problem as before. So we got 23 is going to be beyond, but that's okay. Now, we could have scaled this differently, or we could have started at a different point. If we had started at 1, you could see all these numbers would be upped by 1 unit, and that would stop us at 23. So maybe if you wanted to do that, you can certainly do that, and that way it fits all on your scale a little nicer. That's perfectly fine. Just make sure you count it correctly. So there, that's even better. So we got a 1, we got a 23, four is going to be right in the middle here. 6.5, so 6 is there, so 6.5 would be about 3/4 of the way. And then 7, so which is pretty close. All right, so there's our 5 numbers. So now we got to connect down the middle. And then connect the tops of the first, or the middle 3. Tops and bottoms. All right, so there's our box plot. Now we can really see that 23 is an outlier. It's way up there. And again, just to kind of jump into the last part, it's talking about outliers. We know that those are values that are very far away from the vast majority of the other values in the data set. So 23 is more than likely an outlier. So that wraps up this section. So now look for review, and we got a test coming up shortly thereafter. So we'll see you in upcoming videos. Take care.